All right, so now let's see this particular question. So in this question, we are given an integer array, right? And the elements of this particular array actually represents a permutation, right? What we need to do is we need to implement the next permutation that rearranges the numbers into the lexicographically next greater permutation, right? And if there is no such permutation exist, we can just rearrange the numbers in the ascending order, right? Sorted in the ascending order essentially, right? And that will be the lowest possible order, right? And also, like they have given the definition of a permutation, you can just read this. A permutation of an array of integers refers to a specific arrangement of its elements in a sequence or linear order, right? So essentially, in simple words, what they are trying to say is that the elements of this particular array actually represents or form a permutation, right? What we need to do is we need to find the lexicographically next greater permutation possible using these particular numbers, right? So for example, if 241750 is my current permutation, which is given in the input array, I need to find the immediate next greater permutation, which is possible, right? And when I say permutation, you can actually think of it as a number. If I say 241750, this 241750 is a number. I want to find the next greater number than this 241750, which is possible to be formed only by using these six numbers or all these numbers which are given in the input array, right? That's what I need to do. So now maybe you can just pause this video and try to think of a solution. And once you are done, you can just come back and check the solution here. Okay, so now to solve this particular question, see, essentially, if you think about it, is what we need to do is we need to find the next greater permutation than the current one, right? The immediate next. And since I want to find the immediate next greater permutation, I will have to make, obviously to get a greater number, I will have to like increment or, change a lower digit with a higher digit. Definitely, I will have to do that. But the question is, where do I make that particular change, right? If I do that change over here at the first position, it will definitely be giving me a greater permutation, but that will be huge, right? I mean, that will be a huge change and that will definitely not be the next greater permutation, right? If I do a change over here at the last unit place, right, that would mean that it will be, if I can make that change, of course, it will be the next, definitely it will be the next greater permutation, because I mean I'm increasing the value of the permutation overall, and I'm increasing it by the minimal amount, right? Because I'm increasing it at the rightmost place, which is the units place of this particular number, right? So that's why I will be making the minimal change to this particular number, and I will get the next immediate next greater permutation possible, right? So the conclusion is, or the observation is, that whatever change I have to make for increasing this particular permutation, I have to do it uh, at the right most of the array, right? As much right as possible, right? So that's the entire crux of the idea. So what I can do is I can just keep traversing this particular array from right to left, right? From here, from the end to the start. And then I can keep checking if there is any scope of, increasing the current number that I have got using the using all the elements that I've seen so far, right? So in fact, let me just take an example. That way it will be, clear for you. I mean, this way it will be a little complex to understand and explain also for me. So what we can do is, what I'm saying is that I will just start traversing this particular array from here, right? Now, first of all, I'm at 0, right? So when I'm at 0, I will just check if I can get a greater number than this current number, right? By only using the digits that I've seen so far. Now, what is the digit that I've seen so far? I've just seen 0, right? And 0 is the only number that I can make using 0, so I cannot make any change over here, right? So now when I move to the next element, now if you see, I get 50, right? So can I get a greater number than 50 by using only 5 and 0? No, I cannot, because these two numbers are actually arranged in the descending order, right? And so there is no scope of incrementing this particular number, right? So now I will move to the next number, and now I will see that, I get 7, which is again greater than 5. And again, this 750 is the greatest number possible, greatest permutation possible by using only these three numbers, 7, 5, and 0, right? So again, there is no scope of incrementing this particular permutation, right? So I will move to the next number. Now I get 1750. Now I see that 1 is actually lesser than 7, right? And these numbers are definitely not arranged in the descending order. So there is a scope of increasing this particular part of the number And so what I can now say is that if I can just change this particular digit over here to a greater number, then I will be getting a greater permutation, right? And since I have to get the next greater permutation, I will be swapping it, or I will be changing it with a number which is immediately greater than this particular number and is available over here in these digits that I've seen so far, right? And what is that number? If you see, that is 5, right? So 5 is definitely greater than 1, right? And there is no other number in these numbers which is lesser than 5 and then greater than 1, right? We have 7, but then 7 is greater than 5. So now if I swap 7 and 1, I will be getting a greater permutation, but that will not be the immediate next greater permutation, right? So that's why I have to only swap it with the immediate next greater number, which is available to me in these set of numbers that I've seen so far, right? Which will be 5. So now I will just swap 1 and 5. And so what I will get is 2, 4, 5, 7, 1, and 0, right? Now this will be the permutation where I will be at, right? Now what I need to do is I've already like increased the permutation, right? By swapping this and this number, right? So I'm already like done increasing the permutation, but now what I will have to do is I will have to minimize the number that is getting formed by the rest of the numbers over here, right? Why I will have to minimize it? Because see, the number is already increased, right? But since I want the next greater permutation, I have to only increase it to the next greater permutation, right? And so I will have to minimize, the number which is getting formed by the rest of the digits over here. Now this, if you see, these are arranged in the increasing order, and obviously they are arranged in the increasing order. That's why I reached till this particular point, right? I know for a fact that these three numbers are arranged in the increasing order. So this will be the maximum number which is possible by these three digits, right? And now I have to minimize it. So what I will do is I have to like actually sort them in the ascending order so that I get the minimum number possible out of these three digits. And so if I essentially just reverse the order of these three digits now, I will be able to sort them in the ascending order and get the minimum permutation possible out of these three digits, right? So now as a second step, I will just sort these three numbers in the ascending order. That is, I will just reverse their order and I will get 017. And that will be my final output if you see 245017, right? This I can now safely say is going to be the next lexicographically greater permutation, the immediate next greater permutation, right? So I hope you understood, the crux behind the solution. The algorithm, just to repeat, what we have to do technically is we have to keep traversing this particular array, and we have to keep traversing till I find an element uh, which is actually lesser than the previous element that I saw, right? If the moment I get such an element which is lesser than the previous element that I saw while traversing from right to the left, from the end to the start, then that's where I have to make a swap, right? And then what I will do is I will again, I will just mark this particular index, right? And then what I will do is I will just search for the first greater element uh, than this particular element, right? And the moment I find the first greater element, I will just do a swap of these two elements with each other, and that will complete my step one, right? And then for the remaining elements, which is essentially after this particular index that I marked over here, which I swapped, I will just reverse the order of those remaining elements, and that will be my final permutation. That will be my final output, right? So that is essentially the entire algo. I hope you understood it. And now let's just code this particular solution together. All right, so now let's implement the solution that we discussed, right? So first of all, let me just declare a function. I will call it as next permutation, right? And this will accept an integer array, right? Now what I will do is I will just capture the length of this particular array like this, right? And now what I will do is I will just declare a variable and I will call it as num and I will initialize it to -1, right? And how I will use this particular variable is I will use this variable to actually track the index that I find where I have to do the swap, the initial swap, right? So that's where I will make use of this particular variable. I will just store the index of that specific element that I need to swap in this particular variable, right? So what I will do is now I will just start traversing the array, from right to left, that is from the end to the start, and I will start from the second last element, right? Because anyways, there is no use of scanning the last element, because I cannot do anything with just one number, right? I need at least two numbers, as we saw earlier, to actually do some change if possible, right? To actually increment that, right? That permutation. So what I can do is I can start from my second last element, and I can go up till the 0th index. So I will have to give -1 over here, and I will go in the steps of -1, right? And in every iteration, what I will now do is I will check if my current element is actually lesser than I plus 1 or not. If element at the ith index is actually greater than the I plus 1 index or not. Essentially what we are saying is if the current element is actually lesser than the previous element that I've seen or not, right? And the moment I get the first such element, what I will do is I will assign that index, that is I, to my num variable to keep a record of it, right? Like this. And then I will just break the loop, because now I have got the first number from the right where I have to make the swap, right? I hope this part is clear. And then what I have to do is, I will come out of the for loop, and now see, I will check once if my num is, equal to -1 at the end of the loop, right? And it will be -1. It will retain the value of the -1 if I never change it in the for loop, if this condition never satisfies, right? And this condition will never satisfy if, all the elements of the array are actually, sorted in the decreasing order, right? And if they are sorted in the decreasing order, they are already forming the highest, the greatest permutation possible, right? And there will be no possible permutation greater than that, right? And so now, as per the question, what I can do is I can just return the uh, lowest possible permutation using all these numbers, right? By sorting them in the ascending order, right? So essentially, I can just reverse the order. If they are already sorted in the descending order, I can just reverse the order, and that will give me the ascending order, right? So I will just check if I don't get such an index, right? If my num is equal to -1, then I will just reverse the array, right? Like this. And see, I haven't implemented this reverse function over here. What I will do is I will quickly implement it, and it's pretty easy to implement. Uh, what we can do is we can just declare a function over here. It will accept an array. It will accept the left pointer and the right pointer, like this, right? And now what I will do is I will just run a while loop till my left pointer is lesser than right pointer. And what I will do is I will keep swapping my left element, right, with my right element, like this. Let me just copy quickly and change this to L and this to R. This way I can just do, the entire swapping between these two elements in one go, right? So that's what I'm doing. And then finally, I will just increment my left pointer by 1 and decrement my right pointer by 1, right? So this will just reverse this input array in place, right? So we don't need to return anything. We are doing this swapping in place. So this reversal will happen in place from left to the right pointer, right? So that's my reverse function. Now what I can do is I can use this reverse function and reverse the entire array starting from the 0th index till my last index, that is n minus 1, right? This will just reverse the input array, right? And if my num is not equal to -1, that is, it is greater than, it is something other than -1, that is, I actually got some index where this particular condition satisfies, right? So then what I have to do is, essentially, I can put it in the else condition. Now what I have to do is, I have to find the immediate greater element than the element which is currently placed at the index num, right? And then I have to do that swap, right? As we have seen earlier. So now what I will do is I will again start, scanning from the right of the array. So I will say for I in range from n minus 1 this time from the last element till num, right? So I am just going to scan till the index that I've found, right? Because over there only, from within that range only, I have to find the number greater than the number which is currently placed at the index num, and which is immediate greater. So I will just keep scanning from there till the num, from the last till the num, and I will do it in the steps of -1. And now I will just keep checking if my current element is actually greater than my array of uh, num or not, the element at the num index or not. right? And if the moment I find such an element, that would mean that is the first immediate greater element than the number placed at num, right? Why? Because see, I'm traversing from the right to the left, from the end to towards this particular number, right? And I know for a fact that all the numbers before this particular num index are sorted in the increasing order, right? So I can very safely say that the moment I find a number which is greater than the number placed at the current num index, that will be my immediate greater only, because if I move forward, I will definitely get numbers which are greater than, this current element. So that's why I will just make a swap with this particular number, the current number, with the number which is currently placed at the num index, right? I can safely do that. So now I will just make this swap like this in just one line again, and I can just again copy this, paste it over here, and change this to I and this to num, right? That's it. Now I have done the swap, right? And I can break from here because I don't want to proceed further. I've got the first greatest element, the immediate greater element, then the current element at num. And so I can break over there. I've done the swap, I can break, right? So that is done. And as a second step, as we had seen, that the remaining elements, that is from the numbers from the index num plus 1 till the end, now I will have to reverse their order to get the minimum permutation possible from those remaining elements, right? So what I will now do is I will again use my reverse subroutine, and I will call it on this array. And now my starting position will be num plus 1, right? And I will go till the last element, and I will reverse this entire array. I mean, all these numbers in place in the same array, and that will give me the next immediate greater permutation than what was represented by the input array, right? So that's it. We are already doing this in place, so we don't need to return anything. And I think we are good. Now what we can do is we can quickly test it. So what I'll do is I'll declare an array over here, and I will just use the sample test case that we saw earlier. I will just copy it from here quickly like this, right? Now what I will do is I will just print this particular array first, right? And then I will call this function next permutation over this particular array, and then again print it, right? So that we know like how the array looks before and after calling this particular function, right? Now let me just run this to see what we get, right? So this is my original number 241750, and the next permutation that we get is 245017, which is exactly the permutation that we saw in the explanation part as well. This is the immediate next greater permutation than the current one, right? Then the input array. So that's the entire solution. I hope you understood it well, right? And the time complexity and space complexity, time complexity will be order of n over here because we are just traversing the array linearly, right? In the worst case, we will be doing it twice. Even for reversal also, it will be order of n, right? So overall time complexity will be order of n. And the space complexity, since we are not using any extra space over here, it will be constant. It will be order of 1, right? So that's the entire solution. I hope you understood it. And now I will see you in the next video. Thank you.